line tests, right? So if you can pass a vertical line across and it only touches in one spot every time, that thing is considered a function. We can perform operations in between two functions. So we can add two things together. So like f of x plus g of x, or they can write it like f plus g with an x. This is the same thing, okay? So there's two different notations. We can add a function together and make a new function, h of x, like that, or we can write it like that. That really means add those two functions together. So f of x is equal to x squared, and g of x is equal to negative x plus 5. So if we're going to add them together, basically you just put it together. F of x plus g of x, well, f of x is x squared plus g of x is negative x plus 5. So if we add them together, this gives me a new function, h of x is equal to x squared minus x plus 5. You just basically simplistically add it, okay? If there was an x in one and an x in another one, it would become 2x then, okay? Now, if we take a look, if they wanted us to add it, we could do this a couple different ways, okay? If we look at the different points, like, for example, this point here, this is at 2. Oh, this is not a good one, and this one is at 9. So the f of plus g of x, I would expect to be at 3 plus 9. I'd expect it to hit way up here at 12, okay? This one here is at 1. This one is at 4. So guess where that f plus g of x hits? At 5, okay? So the x values stay the same. The y value changes because you're adding the two functions together, okay? So if I wanted to know what the answer of h of x is at negative 1, what would you do? You'd find it here, 1, and here at 6. 1 plus 6 gives us 7, so you could find those pieces, okay? Same thing happens for the difference of functions. Okay, because I'm not going to stop and change attendance. Okay, so difference, same thing, except for you have to subtract. So let's say we have f of x is negative 2 and g of x is is x minus 4. And we want to find f of x minus g of x, or they write it as f minus g, right? So that's like negative 2x minus x minus 4. That's what it's like. You have to remember that that subtraction goes into both parts of that g of x, okay? That gives me negative 3x plus 4 as my new function. And the same thing, you could do a subtraction. You could find out what f was. You can find out what g was and do f minus g, and that'll give you your point of h at that x. Okay? Now to find domain, I really want to talk about this domain section. The domain of a combined function formed from the sum or the difference of these things is common to the individual examples. For example, if f of x, what does this say? X is greater than or equal to 0. And the domain of g of x is x has to be less than or equal to 10. The domain, when we add these two functions together, will only be between the 0 and 10, the ones that they have in common. Okay, so the commonality. So If the domain is common and it says x is an element of the reals for the first one and x is an element of the reals for the second one, then the domain for both functions are x is an element of the reals, okay? If one says x is an element of reals and the other one says x has to be greater than 5, well, the domain for the combined function is x has to be greater than 5, okay? So it's kind of like this commonality thing, yeah? You should be able to subtract points, yeah? It's not working. Well, let's look. Let's come back up here. So we have f of x minus g of x. So if we look here, this one's f of x, right? So that's at 2. And our g of x at that x value is minus 3. And so it should be 2 minus a minus 3, which will give us 5. But it's at negative 2. That's a weird graph. Okay, so let's just check it here. If we check it here, our x value was 1, right? Negative 3 times 1 is negative 3 plus 4 is at negative 1. Positive 1? Yeah. And isn't that what we said we were supposed to be at? No. Negative 3 times 1 is negative 3 plus 4 is positive 1. Okay. G of x is negative 4, rise over run, that's a good line. F of x is negative 2x. Is this the right f of x? I think these two graphs are written as the wrong ones, right? Because if we graph negative 2x, that's 0, right? 0 and 0. So this line should be f of x. And this darker line should be h of x, basically, right? So if we follow that, this is a negative 2. Negative 2 minus, it still isn't making sense, is it? It would be positive 1, and that's what we got in the formula, right? But the graph is still not right. This graph is still not on the right line, though. This graph here, if we look at this, if we look at the equation we wrote, that's your y-intercept is 4, and it's not at 4. So this line is incorrect. But if we did the subtraction, we got negative 1, and if we use the formula, we got negative 1, right? So my graph is just messed up completely, is what you're telling me. But you should still be able to do the graph subtraction and get the proper answer. It's just that I gave you the wrong graph. Do you guys get that? Let's pick a different x value, just so that we know we're good. Let's pick 2. So we have a value at negative 4, and we have a value at negative 2. It's f of x minus g of x, right? So f of x is minus 4 minus a g of x, which is minus 2. So we actually get an answer of negative 2, right? That was when x equals 2. If we come into this equation, we get negative 3 times 2 plus 4 negative 6 plus 4, we get an answer of negative 2 as well. Okay? It's just that my one line is graphed wrong and the other line was labeled wrong, right? I'm sorry. Okay. Good catch, though. So, domains, you just have to combine them, right? And figure out where are they both part of that domain. And to find the range, you have to use the graph. So once you've combined it, look at the graph and you can find the max and min for that point, or the table of values, max and min for that point. We'll show you how it works here. Here they give us some points and they ask us to find f plus g of x. Do the x values change? No, it's just the y value that changed. So at point of negative 6, if we're going to add them together, we're going to take f of x is 4 and g of x is 3 and add them together to get 7. Do we have a negative 4 point? So this one's done, this one's done. We have a negative 4. We have a 2 and a 6 to give us 8. Do we have a 0? We have a negative 2 and we have a 0. So let's do the negative 2, a 0, and a 9, which is a 9, and we'll do the 0, which is a negative 2 and 12, so that's a 10. Okay, so the x values stay the same. The y values are what you're adding in the function. Yeah? Okay, because this is saying f of g of x. So the x value stays the same, but the y values you're adding. What's going to go on here? They're going to what if it said g minus f? Then you pick the g's first, then subtract the f's. Okay? But because it says f minus g, we're going to pick out the f's first. So negative 6, the f was 4. 4 minus 3 is, okay? From this 0, 12, and this 0 and negative 2. Negative 2 plus 12 is 10. Okay? So negative 4, the f is 2. So 2 minus 6 is negative 4. Our negative 2 values, our f negative 2 is 0. 0 minus 9 is 9. And then our 0 values, we're at negative 2, and we're subtracting 12 to get us negative 14. Okay? So when you add or subtract functions, the x values stay, right? We're just adding the y values. Because functions, f of x and g of x and h of x all stand for y, right? We always say that's the symbol of y. So when we say h of x plus g of x, it makes sense that we add our y's together. So consider f of x equals x plus 1 and g of x is equal to 2x minus 5. What's the function of h of x is equal to f of x plus g of x? What should we do? I'm going to add them together. So we get h of x is equal to x plus 1 plus 2x minus 5, right? F of x plus g of x. Some people would skip that above step and just add them, right? Like Dylan was here. So we get 3x minus 4, okay? Now, how would I graph these things? These are all lines. Do we know how to graph things that are linear in slope-intercept form? I wouldn't even worry about adding them together, I would graph them all as lines because I've solved for the equation already. So So my first one is f of x. It's x plus 1. So it's at 1 here, and then the slope is up 1 over 1, up 1 over 1, up 1 over 1. And so I would draw with my ruler, because you can all see me with a ruler right now, that, and I would label it f of x. I would take another color or something to make it equal, and I would do my g of x, which is 2x minus 5. So what does that mean? At minus 5, I'm here, and it's a positive 2, right? What does that positive 2 mean? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Oh, so I draw my line. Oh, with my ruler that I've got going on here. That's some awful lineage, okay? And I'd label that g of x. I really do hope that you use a ruler, though. Yeah, that's looking nice. Now, the last one, when I look at it, I could graph this, 3x minus 4, just like I graphed everything, or I could come down here and find the point of each x's and add them. Which way do I find easier? Just graphing this thing. But if it becomes like this weird kind of x to the 5th, x to the 4th, I don't know how to graph that. Then I might think about adding every single x, or every single y value of that x. So I've got 3x minus 4. So minus 4. Now this makes sense because when you add minus 5 and 1 together, you get minus 4. And we go up 3 over 1. And this makes sense when you add negative 3 plus positive 2, you get negative 1. Up 3 over 1. Up 3 over 1. And you get this other line in here that you're going to call, what was it, h of x? Okay, some people even write the equation right next, but please label it. Some people will draw it with 3 different colors. It just makes it easier to see and tell them apart. But make sure you label which line is which, with f of x, g of x, and h of x. So let's look at another one. We get x squared as, oh, we never talked domain and range. You're right. What's the domain of a line, you guys? And what's the domain of the line? Yeah, x is element rails. So the final one was a line as well. And if we combine domains, x such that x is an element of the reals. And when we look at the y values, they continue on forever as well, right? So y such that y is an element of the reals. Determine the values of f of x, g of x, and h of x when x equals negative 3. What would you do there? Well, we could come to the graph and look at negative 3 and read off the graph, especially if you used a ruler. Not mine. But what else could we do? You could put negative 3 into each of these. Negative 3 plus 1, that's negative 2. Negative 3 times 2 is negative 6 minus 5, that's negative 11. Right? Negative 3 times 3 is negative 9, minus 4 is negative 13. So if you need to, you can always plug into the equations the x values and solve for the y's. So, how do you find this next equation? You know? We got to subtract, right? So we get h of x is equal to, sorry, x squared minus 4x minus 4. So that gives us h of x is equal to x squared minus 4x plus 4. What is that thing? That's a quadratic, is it not? What are quadratics? Parabolas. Mm-hmm. Yeah, because I had to put a bracket around the g of x because it was minus g of x, so that negative has to go into both terms. Okay. So when we look at that and we go to graph that, f of x is a little harder to graph. F of x equals x squared. So when you plug in 0, 0 squared is? When you plug in 1, 1 squared is? And negative 1 squared. 2 gives me 4, and negative 2 also gives me 4. 3 gives me 9, and negative 3 gives me 9. That's about all I'm going to be able to graph. Now, when we look at the domain of this, you guys, what do you see? Domain has to be, x has, no. Domain goes on forever, sorry. Y is greater than 0. Okay. The second one, so I better label this f of x. The second one is 4x minus 4. That's a line, right? So when we do that, 4x minus 4, negative 4 is our intercept is here, right? And then our slope is 4, up 4 over 1. We get this line here. Hopefully your line looks nicer than my line, but that's g of x. How are we going to graph that last one? We could take the points if we wanted to and subtract them, right? So, like 0 minus 4, or minus a minus 4 is positive 4, right? So I can guess that I'm up here, 1, 2, 3, 4, here, because that's this minus that, right? But do I really want to go out and do this? Probably not. What else could we do? What's our original? This is x squared minus 4x plus 4. My y-intercept says that's 4. Remember the last number on the standard is 4? We could factor this and come up with the x-intercepts if we wanted to, right? What else could we do? We could do a table of values. Negative 2, negative 1, 0, 1, 2. You could graph it like that. You could plug this into your graphing calculator and look up your table of values. Can someone plug this into their graphing calculator and let's find some values? X squared minus 4x plus 4. I know you can do it mentally. Negative 2 squared is 4, plus 8 is 12, plus 4 is 16 or something like that. Negative 1 squared is 1, plus 4 is 9. If we put 0 in, we get 4. If we go 1 in, 1 minus 4 is negative 3 plus 4 is 1. What do we get for 2? Do we get 0 or do we get 4? 0. Okay, what do you get for 3? Is it back at 1 now? Yeah. And what about 4? 4. And 5? Do you see? I see a parabola now. Do you see the parabola forming in here? 6. So what's your vertex then? 2 and 0, right? That's your vertex. So our vertex is 2 and 0, and then around from there, 1 and 1, 3 and 1, 4 and 4, and 5 and 9. Do you see we just shifted the parabola over? Right? But it's there. You can draw it. You can figure out ways to draw it. probably the easiest way to figure out a way is to do a table of values. Whether you do it manually in your head, whether you plug it into your graphing calculator, just make sure that you know to graph it, you can come up with a table of values very quickly. Okay, so what's the domain and range then of the new graph? X such that X is an element of the reals. What's your range? And realistically, when we add the ranges of the two original ones, the intersection is y is greater than 0. Okay? Is there more? Sometimes they're rude and don't give you the equation, so you have to actually do it in your head. So, what's f of x plus g of x? And sketch it. What do? You take the points here and here and add them. So I have 1 and -3. That becomes -2. I don't like certain points because they're harder to add, right? Like this looks like half and half, so this is -1/2, and that's +1/2, so that'll be -1. 0 and 0, 0. This is -1/2, +1/2, so that'll be right in here. No, it won't be. Let me think about that again. It would just be 1, right? You're right. No, that doesn't. -1/2 plus 1/2 is 1. It just doesn't look right. It's not right in the center, but look down here. It's not right down in the center either, right? 3 plus -1 is 2. Can we see what's happening, you guys? It's going up 1 over 2, up 1 over 2, up 1 over 2, right? It's forming a... So if you notice a pattern after a while, you're picking points. It goes up 1 over 2, up 1 over 2, up 1. So we can just carry on. We don't have to do the math in our heads if we notice a pattern. And then draw that line. Okay? If you notice some of a pattern, you can actually do this. The last thing that they might ask us to do is to evaluate some things. F plus g of -5. What does this really mean? What's f plus g when the x value is -5? So I go, where's x -5? Right here. So at this point, that's at 3. And at this point, 6. And it's saying f plus g. So 3 plus 6 is 9. You could just write 9 if you want. Now this one says f minus g at x equals 3, right? So at 3, we have a value of 1, and we have a value of 2. Which one's g and which one's f? 1 is f, and 2 is g. And so this is where you have to be careful. It says f minus g, so I'm going to write 1 minus 2. If it said g minus f, I'd write 2 minus 1. Right? So you have to follow order. 1 minus 2 is -1. Can you try C? Do you want to try C? Or you guys already tried C? G minus f at 4. So at 4, that's 0. And up here it's 3. So g minus f, that's 3 minus 0, which is 3. Do you get that? Do we have to do more? Doesn't matter the order. You're right. If it says F plus G, I would try to consistently write whatever F is and then write whatever G is so you don't make the mistake with subtraction. Yeah?
Can we just say f of x does not extend that far?
So for E, why can't you do F plus G of 5? You can't see 5. It doesn't extend. It's not part of the domain, right? The x domain for f of x doesn't follow that far, so it's not part of f of x, or it's not part of the domain of f of x. 5 is not in f of x's domain. Is the real reason, right? It doesn't exist, right? You can write D and E there because it doesn't exist. All right. Add a sketch of the combined graph, F minus G. So what do we have to do here? At every point we have to take the F and subtract the G. So right here we're at 8. 8 minus 4 is 4, so that's that point. Then I'm here at close to we're close to 5. 4 and a half, you're thinking right here? So 4 and a half minus 3 is 1 and a half, right? And then here we have 2 minus 2, which is 0. And here we have 1 half minus 1, which will be negative a half, right? Here we have 0 and 0. 0 minus 0 is 0. Here we have 1 half minus 1, which is negative a half again. Here we have 2 minus 2 is 0. Here we have 4 and a half minus 3, which is 1 and a half again. And back up here, 8 minus 4 is 4. Now there's arrows that carry on, but we can look and we can see that this is kind of what we've got going on. And it goes back like that, right? We're going to assume that it carries on forever because we can't see the rest. But as long as we do, and you should do every single point because sometimes little things like this happen, right? So you try and go across as you may. Okay? Then I wouldn't draw the arrow. Okay? Is this okay though, this stuff? Okay? Now, I can give you the homework assignment, but really what is for homework right now? I want you guys to work on your review. Okay? Your review is due tomorrow. If we have extra time, we'll work on Chapter 10 assignments. I will give you a Chapter 10 assignment for those of you that are going to work in Period 5 here or done your review already because you're just that good. Or you did it during Chapter 5 yesterday. I don't know. I don't know what you guys all do with your time. So, we're going to look. And I want you guys to try from 483. Let's do questions 2 and 4 and 6 and 9. 2, 4, 6, 9. And should we call that done? 2, 4, 6, 9? I should have said 8, and then you could have said, who do we appreciate? Okay, 2, 4, 6, and 9. Sure. Sometimes we do. Usually we sing it right before you guys walk out the door. Who am I supposed to help? Okay. so what's 2 cubed?